Welcome to Tennessee's At Home Learning Series for Math. Today's lesson is for all our 8th graders out there, though all children are welcome to tune in. Today's lesson is the 8th in our series. My name is Candace Thompson, and I'm an 8th grade math teacher at Oakland Middle School in the Rutherford County School System. I'm so excited to be your teacher for this lesson today. Welcome to my virtual classroom. If you didn't catch any of our previous lessons, you can find them on the website that I'm actually displaying now, as well as student packets to go along with our lessons today. If you haven't seen any of our other lessons, you can still tune in to today's lesson, but it might be more fun for you to first go back and watch our other lessons, since we'll be talking about things we learned previously. Today, we will be learning about writing an equation for a linear function from 2 points in mathematics. Before we get started, to participate fully in our lesson today, you will need the following: paper and pencil, and a surface to write on. A calculator is not required, but it may be used to check your calculations. Optional, but would be helpful if you have this, is graph paper. If you don't have graph paper, you can still participate in today's lesson. Okay, let's begin. Today we are going to develop strategies writing equations for linear functions using ordered pairs. But we will also continue practicing our interpretation of the linear function in the context like we've been doing this week. Let's connect back to some prior learning by doing a quick inquiry. What is the same and what is different here? Looking at these four representations, what is the same and what is different here? Let's think about how these could be grouped and identified. Did you see any of these? Let's think aloud together. So every box shows a relationship between distance and time. Get that out of the way. Boxes A and B and C also represent the constant rates of change over time. Boxes A and D represent positive rates of change and have an initial value of 0. Boxes B and C represent negative rates of change. Did you notice that box D doesn't have a constant rate of change? Awesome. Let's keep in mind today that linear functions can be modeled using graphs, tables of values, and equations. Let's look a little deeper at a table of values. Let's recall what we know about a table of values. This table shows us the relationship between distance and time. The table groups the information into ordered pairs of time and distance. If we look at the first row right here, we see that at time equals 0, the distance is 20. So we can write this as an ordered pair like this: 0, 20. Now you try. Write the other 2 sets of ordered pairs from the table of values. I'll highlight the ones I'd like you to do. Let's see what you wrote. Did you write these? 1, 18, and 2, 16. Great. Now let's review this from reading a graph. We've done this on lessons earlier this week, but let's review briefly. Take a look at this graph here. Let's look at the line placement to find a point of the graph. There are several, but look first for any clear integer values, or in other words, what I always say is where the line goes perfectly through the grid. I see one here at 1, 1. This point on the line can be represented by the ordered pair 1, 1, where the first one represents the horizontal shift and the second one represents the vertical shift. Now see if you can find at least one other point that can be represented by an integer ordered pair. In other words, that goes perfectly through the grid. It's difficult to see on these graphs sometimes, but I saw at least 2 others. Did you find one of these? I found one at 9, 12, and at -3, -6. Great. Now you can easily identify ordered pairs from a table of values or from a graph. Now let's use those ordered pairs to move to the next part of our lesson today. Let's look at a situation described in words and a table of values. And just for some context for you, alpacas are grazing animals that are raised for their wool fiber, like sheep. The Lima family owns 10 acres of land. They want to buy more land and start a ranch. The amount of land they need is a linear function of the number of grazing animals they plan to have. The family decides to raise alpacas. The table gives the number of acres they need for different numbers of alpacas. Now, let's think about a couple questions together. We want to write an equation to model the data in the table. We know that we can use the slope-intercept form of a linear equation to do that. Recall what we were talking about, the y equals mx plus b form, where m is the slope or rate of change, and b is the initial value or y-intercept. So since we have a table of values, we can write ordered pairs like we did at first. Take a minute to look again at the table and write all the ordered pairs. I wrote these three down. Did you? 10, 25, 20, 40, and 30, 55. Great. Now recall that we can use those ordered pairs to calculate the slope or the rate of change. We only need two. You pick whichever two you want to work with. Remember that this is what the formula looks like. So the slope formula is y2 minus y1 over x2 minus x1. In this case, I'm going to use these points, 10, 25, and 30, 55. So I'm going to call this x1 and y1 and x2 and y2. So when I plug that in the formula, I have 55 y2 minus y1, which would be 25, over x2, 30, minus x1, 10, which gives me 30 over 20, or 1.5, or 1.5. How did you do? Awesome. Now, what does that mean in the context of this problem? What does a rate of change of 1.5 mean in the context of this problem? Right. It means that for every acre of land, you can increase the number of alpacas by 1.5. Now, no rancher is going to increase their flock or herd by half an animal, but we know that the mathematics is here to model the situation as a whole. Since we found the rate of change, how can we find the initial value or y-intercept? Sometimes the table of values will give us that number, but in this case, the table of values doesn't tell us. So we can find the initial value by substituting the rate of change, which is 1.5, and one pair of values from the table into the slope-intercept form of a linear equation. You can use any one of the ordered pairs that you want to. I'll walk you through this one to find the initial value. Let's use 10, 25. I'm going to do my work up here. So we're going to use the point 10, 25. All right, so we're going to use the slope-intercept form, y equals mx plus b. And I'm going to plug in my values. So my y value is 25. My slope is 1.5. When y is 25, x is 10, and I'm solving for b. So I have 25 equals 15 plus b. Now let's stop here for just a second before we do this algebraically. 15 plus what equals 25? Correct, 10. But if we're doing correct mathematics, we'll go ahead and subtract 15, and we have that b equals 10. So either way is fine. Don't make it harder than it has to be. Did you follow the pathway? Now, we know that the rate of change, or the slope, is 1.5, like we have here, highlighted in green. And the initial value, or the y-intercept, is 10. We can write in the equation of the linear function this way. So to model this situation, it would be y equals 1.5x plus 10. Let's try another one. This time we'll use a graph. So let's use this graph here. Take a minute and see if you can identify at least 2 integer points on the line on this graph. In other words, can you find 2 points that go perfectly through the grid? Here are the ones I found. Compare them to the ones you found. So I have -4, 4, and I have 4, -2. You might have thought you found a couple others. Graphs are often more difficult to read for specific points. They are very good at showing us general trends, but for individual points, we usually like something else. So now let's try to use these 2 points to help us write the equation of the line. What's the first thing we need to do here? Right, we've got to calculate the rate of change, or the slope. Remember, you can do that by calculating rise over run, or we can use the slope formula, y2 minus y1 over x2 minus x1. So let's use these 2 points that we have here. We have -4, 4, and we have 4, -2. So I'm going to label them accordingly. I have x1 and y1. I have x2 and y2. So I'm going to do y2, which is -2, minus y1, which is 4, over x2, which is 4, minus x1, which is -4. So when I calculate that, I get -6 over 8, which simplifies to -3 over 4. Now, what's next? Right again, we need to find the initial value, or the y-intercept. Now use one of the ordered pairs and the slope to substitute into the form y equals mx plus b of the linear equation to find b. You try this for a minute. Now, you may be thinking, well, with a graph, I can easily see the y-intercept. It's just where the line hits the y-axis. But as you can tell, that's not really a distinct point. I can't really I'm going to have to estimate what that is. Whereas if I plug it, if I use the slope-intercept form, I'm going to get a more exact answer. So I'm going to start with the slope-intercept form, y equals mx plus b. And I'm just going to plug in what I know. I'm going to use one of these ordered pairs. So I'm going to use, let's use -4, 4. So for y, I'm going to plug in the y value, which is 4. For m, what would I plug in? Correct. I'm going to plug in -3/4. What's the value of x when y is 4? -4 plus b. So now I'm going to simplify my work. I get 4 equals -3/4 times -4 is equal to +3 plus b. Now remember, think of it this way. 3 plus what equals 4? Correct, 1. Or we can move my 3 over and we get b equals 1. So now we have that the rate of change, or the slope, is -3/4 and the y-intercept, or initial value, is +1. So what is our final equation of the linear function? Good. Our equation is y equals -3/4 x plus 1. Are you getting the hang of this? I know you are. Let's do just a little more practice. The cost of a craft project is the function of the number of bundles of yarn that it requires. The table shows the cost of projects that use different amounts of yarn. Take a minute to think about what you need and what you can learn from the table in order to write the equation of the linear function that models this situation. Did you identify at least 2 sets of ordered pairs? I'm sure you did. There are 3 in the table that we could use. We have 5, 11.25, 8, 13.50, and 12, 16.50. We are ready to calculate the rate of change. Pick 2 of the ordered pairs. Any 2 will work as long as your arithmetic is correct. Take a minute and calculate the rate of change using the slope formula. Okay, so I'm going to use these 2 points here. I'm going to label them x1, y1, x2, y2. So I have y2, or 1650, minus y1, or 1350, over x2, 12, minus x1, 8. And when I work that out, I get 3/4, or if we want to use it in the context of this problem, which we're talking about money, we could convert that to a decimal and say 75 cents. So the slope, or the rate of change, is 75 cents for every bundle of yarn. We're almost there. Now use one of the ordered pairs and the rate of change to find the initial value, or y-intercept. So I used this ordered pair here. So I'm going to use the slope-intercept form. My y value is going to be 1350. I just found that my rate of change is 70.75 or 75 cents times, what's my x value when my y value is 1350? It's 8 plus b. And so that simplifies to 1350 equals 6 plus b. So you can think of it a few different ways. What plus 6 gives you 1350. And we get that b, or our initial value, is equal to $7.50. So our last step is to put it all together into a final equation model of the linear function. We have our slope, or our rate of change, and now we have our y-intercept, or initial value. Take a minute and write down your final equation. Did you get y equals 0.75x plus 7.5? Great job. Let's take one last minute to think about this in context. What does this model tell us? We can say that the initial cost is $7.50. So the initial cost of this craft project is $7.50 without using any yarn. But for every bundle of yarn we use to add to the project, it is going to be 75 cents, or the price is going to increase by 75 cents. I think we might be ready to give this a try on our own. If we want to model this linear function with an equation, we will need to find 2 points on the line. Take a minute and write down the points you find. You should have found these points. We have 1, 2, and we have 6, -1. Remember that graphs can be very tricky to see clearly where the line touches integer values. So let's use those ordered pairs and calculate the rate of change. Take a minute and work through that process. You're getting really good at this, I bet. So we're going to use the slope formula, and I'm going to label this x1, y1, and x2, y2. So I'm going to put in 2 minus a -1 over, 1 minus 6. And so we should have come up with +3 and -5, or we would write that as -3/5. Now we need to find an initial value. Choose one of the 2 ordered pairs to work with along with the rate of change. Take another minute. All right, so I used this point 1, 2. So I'm going to start with my slope-intercept form. Okay, I'm going to use this y value 2 and this slope, or rate of change, of -3/5. Then I'm going to plug in my x value, which is 1 when my y value is 2, plus b. So then I come up with 2 equals 3/5 plus b. I'm going to add 3/5 to both sides, and I get that b equals 2 3/5. Now put it all together. Write it into the equation model. We've got our slope of 3/5 and our y-intercept of 2 3/5. Check yours against mine. I came up with y equals negative 3/5 x plus 2 3/5. So you'll see this is a really good way to find your y-intercept of a graph when it's really hard to see that exactly. I think you are ready for some independent practice on your own. So, terrific work today, kiddos. Today we explored strategies for writing an equation for a linear function from 2 points in mathematics. After this lesson, you will have a few problems to practice on your own using graphs, tables, and descriptions of linear functions in context. I will show you the independent practice problems now. So remember, you can go to this screen that I am looking for, or that I'm on, excuse me. We have our schedule here, and then you can go all the way down to Math Grade 8 Student Packet. Good luck and do your very best. I enjoyed exploring writing equations for a linear function from 2 points in mathematics with you today. Thank you so much for inviting me into your home. I look forward to seeing you in our next lesson in the Tennessee's At Home Learning Series. Goodbye.